Yeah, this is honestly my first one of these, but I guess if you want to start by introducing yourself, uh,
Sure.
your position right now with MIT and at the Concrete Sustainability Hub.
You got it. Yep. So my name is Jeremy Gregory, and I'm the research scientist at MIT in the Department of Civil and Environmental Engineering, and also the executive director of the Concrete Sustainability Hub.
Okay, sweet.
Yeah.
And yeah, I was curious from like what I sent you yesterday. What led you to that topic? Is that I think you didn't know right away from college you want to do that.
Yeah.
Everything
Sure.
smooth sailing.
Yep. I'm a mechanical engineer by training, and my undergrad, master's, and PhD are all in mechanical engineering. And I actually studied mechanical behavior of composite materials for my master's and PhD. And and I was interested in that, but probably about partway through my PhD, I just realized it wasn't what I wanted to do with my career. And I started to hear more about people who were essentially what we'd call now in this field of sustainability science, which was, how can you be quantitative about evaluating life cycle environmental impacts and costs and things like that. And what appealed to me was kind of the analytical part of it, the quantitative element. I didn't really consider myself to be an environmentalist per se or anything like that, but I liked running with numbers, and I did want to, I had questions. What's more environmentally beneficial? And so so basically, I started a postdoc with a group where it kind of started over. It was good to have an engineering background and have a technical background, but a lot of it was just different ways of dealing with numbers to help to answer questions. And so I worked for many years working with a whole bunch of different industries on some of these different topics. I mean, the other area that I would say I work in is industrial ecology, which is looking at sort of industries as ecosystems. And and the research group that I'm in is called Materials Systems Laboratory. And it's because we look at materials throughout their life cycle, whether it be issues about resource scarcity or use or what to do with them at end of life and waste and materials. And so I've worked with many different industries, from electronics industries to automotive. And then about 9 years ago, this Concrete Sustainability Hub approached me and said, hey, can you help us with just apply those same methods to things that use concrete, like buildings and pavements? And so actually that's mostly what I do now is develop and then implement approaches to quantify those life cycle environmental impacts for things that use concrete. And the reason I was interested in that, because I could use those same approaches, but concrete's the most used building material in the world. So basically, if you want to try and have an impact on our materials use, then it's hard to get much more impactful than that. But that was kind of the journey, if you will, of just trying to find something that motivated me. And research is basically, I never thought I was going to get a PhD even, but I just knew I didn't want to get a job as a typical engineer, and it just sort of led me on that journey. And I never expected to be at MIT this long either. I thought I was just going to do a 2-year master's degree. But that was 22 years ago, and I just never left. It just kind of sucked me in. So
I'm curious, did you ever have any kind of like, I guess that you'd say like aha moment when you started? Like you said, you had to start kind of from fresh, like it was useful being an engineer, but when you started learning about this whole field, you started kind of from zero. Did you ever have any moment when you started learning about it where you were like, wow, this really is like either like a bigger issue than I thought, or something like I
yeah,
definitely want to be part of like solving, because it's like the concern is obviously growing. Like we're going to keep building
yeah,
more. Um,
yeah, yeah. I don't think so. In fact, like I've heard it, just like science or research in general is less about sort of eureka or aha, and more about like huh. And I think it's sort of a series of those sort of like like that's kind of interesting moments. But it was mostly, I think, this is sort of early 2000s, realizing that the moment was, wow, there's people like working in this field, right? About how do you actually try and you can have an understanding of materials, but then look at environmental or economic aspects of those materials. And so sort of learning like, wow, this research group already does that, and I didn't even know that was an option, right? Like, had I known that was an option, I would have done my
How old is
education.
the field?
What's that?
Sorry to interrupt.
That's
How
right.
old was the field about? Like when and around did people start trying to answer those questions, trying to actually think sustainably in like life cycle model and like in terms of construction?
I mean, you can point to first work in it even in like 60s and 70s. Like people talk about the first life cycle assessment being one that Coca-Cola did about their bottles, and I think it was late 60s or early 70s. But it didn't really pick up momentum, I'd say, till like late 90s and then early 2000s. And now it's flourishing. You know, there's all kinds of research or consulting opportunities around this, and it's not just being done by engineers. You know, a lot of people who graduate from our group go on to work as like data scientists, because that's a lot of what it is. You know, is like basically how do you analyze data and then use that data to be able to answer a question. And so that can be people who are just have backgrounds in math or computer science or economics or things like that. So, so it's not just engineers.
Gotcha. So like in terms of so the life cycle model, which is basically just from beginning to end, all the like where like all the effort and materials come into place and all the waste that's created throughout like the whole process, looking at it from beginning to end. Which phase of it has the biggest waste?
Yeah. So the approach that we use to answer questions like this is called life cycle assessment. And what we say is that you analyze everything that happens throughout the life from cradle to grave, or some people talk about cradle to cradle, which is actually a book that was published a couple decades ago that kind of talks about how do we reuse materials and things like that. And in order to do a life cycle assessment, you just need to have some basic understanding of what are the processes that are used throughout the value chain. And so it's hard to, you know, and then there are different metrics that you can use to quantify environmental impact. So for example, when people talk about a carbon footprint, we've quantified those life cycle environmental impacts throughout the life, but are only looking at greenhouse gas emissions, right? But you can also do a water footprint. You can quantify things throughout the entire life, or you can look at like non-renewable material usage. And sometimes there are trade-offs among those. Like a good example of that is like, excuse me, air quality and greenhouse gas emissions. So for example, diesel fuel has lower greenhouse gas emissions, but higher particulate emissions associated with air quality. And gasoline is a reverse. It'll have higher carbon emissions, but lower air quality emissions. And so oftentimes you get those kind of trade-offs. But the answer to just about every life cycle assessment is going to be, it depends. You know, like we did a study on hand drying, for example, comparing like paper towels with electric dryers. And, you know, it depends. How many paper towels are you going to use to dry your hands? How long are you going to put your hands under that electric dryer? But you can think about this in the context of just about everything. So, but the idea behind them is to still be able to say, well, if you are going to use this, here's how you should do it, right? And here's the way to kind of give it the lowest environmental impact. So,
yeah, it's honestly kind of insane thinking about like all the different externalities you can try to track. That was like one of the questions I had for you, because in the beginning of like that webinar, I think when you were talking about just like the concrete versus like the wood structure buildings, and you guys were measuring everything in like global warming potential. So like I was wondering if that's like the area you most commonly track, just in terms of like if it's global warming, then it's like what you said, it's about like the types of gases being released into the ozone. It's not tracking like water or like physical pollutants as much. Is that exactly the one that people are most focused on, you say, in the industry, is tracking global warming potential?
Yep. So that is just the technical term for amount of greenhouse gas emissions that occur, and because climate change is like a big priority for people, that is usually the metric that we'll end up using. But like I said, when we do those life cycle assessments, we can calculate, depending on the method, up to 15 different metrics associated with that life cycle environmental impact. Like when you're looking at agriculture, for example, a metric that's often used is called eutrophication, which is the amount of nitrogen that goes into the water, and that happens a lot with fertilizers, and that can kill off plant life and animal life underwater. So depending on which one, or ozone depletion is a separate metric. So for certain kinds of chemicals, that can be important. So there's lots of them, but usually global warming potential, because that's what's driving climate change. That's often the metric that we use the most.
Mm-hmm. It's the biggest one. It's like a global, at least even a concern, but also the one people talk about most. So it has the most demand and pressure.
Sure.
So do you think there's ever going to be, again, in the video, you mentioned that one of like the biggest problems is that like the cost of performing one of these like LCA, like these life cycle assessments. I don't know if you mentioned it further in the video, I just didn't get to it yet. Does the specific builder on that specific project they're the one that commissions that LCA and it's only on that specific project, or is it like per project type? Is it, I guess just if you could just so I can get a better understanding of when the LCAs have to take place, and if it has to happen each time there's a new building, or potentially there could be like in an ideal world, like an organization that's basically done LCAs across the board on all kinds of like project structures and in every kind of category, like ozone, water, so they can just like give out that information so you can follow it. Yeah.
So there is, I'd say, I mean, the short answer is for a lot of projects, you do have to, have someone do a specific analysis. And the reason is, kind of using the buildings as an example, just because I analyze a building, say here in Boston, that doesn't mean the result is going to be the same in Indiana, right? Like we have different building practices, there's different electrical grids, different, lots of things are different. And so you usually do have to have that done separately. So that is why we're trying to streamline that process to make it, much quicker. But I'd say, for buildings, it doesn't happen right now that on every project they have a life cycle assessment done, but there's tons of stuff they already do. They're already looking at costs. They're obviously looking at structural elements. So adding on, an environmental, life cycle environmental analysis is, maybe not even that big a deal because you use a lot of the same information. So at least when it comes to buildings, that's starting to become more of the norm. Now, scaling it up to every product is a bit trickier because in buildings, you may have heard of the LEED green building standard, like people talk about, and that's LEED, Leadership in Energy and Environmental Design. So there's a lot of people who want to have a LEED rating associated with their building of bronze, silver, gold, or platinum. And so as part of that LEED rating, there's different ways you can get points associated with improving energy efficiency or water efficiency, sites and stuff like that. One of the ways you can get points is by using products that have measured their environmental impact. And the way that they do that, so like, let's say I'm a concrete producer, I have an environmental product declaration or an EPD done for my product. And so, and that essentially an EPD is something that says, here is the environmental footprint associated with making this. And in order to do that, you have to have done a life cycle assessment. Now, it turns out that doing those is pretty straightforward because like once you've done it for one type of concrete, it's pretty easy to do it for a whole bunch. So like that ends up being something that's pretty easy. So like industries will usually get together and say, here's the rules associated with how you do this. Now we can all do it together. So for certain, particularly in the building space, doing those life cycle assessments is becoming more common because of this demand from LEED. But that hasn't necessarily translated to other industries like electronics or automotive or things like that.
Mhm. Yeah, so that kind of answers one of my other questions, which is I was going to ask if there's any kind of like body out there, like organization group that like places that's starting to kind of place that pressure on all the different individuals out there to kind of start thinking about this, go around this way and perform LCAs. So LEEDs is the main one, or LEED.
Yeah, I would say in the building industry, LEED is a big push for that. But it's also just that this has become really of interest to architects in particular, and so they're looking to even go beyond sort of what's in LEED. And so I'd say that's another driver of it. But you don't, and in some places now there's starting to be governments that say, hey, we do a lot of construction of government buildings. Can we start asking for EPDs on projects that we do as a government? And so it's starting to move beyond that as well.
Do you think it'll eventually be that everywhere, where it's kind of like a government, like you have to perform an LCA to build this thing?
For buildings, I could eventually see that. Yeah, just because they're so, like it's a significant amount of the environmental footprint associated with it. I mean, kind of like in our building codes, we have energy efficiency standards. So if you look at the life cycle of a building, most of it is driven by the energy consumption of the building, right? What's happening now with doing the full life cycle is saying, now let's also add on what's the embodied impacts associated with the building, which is about the materials production and then construction as well. So we're just expanding that to the full life cycle.
Mm-hmm. Does LCA take? I guess because I remember like when I first kind of heard about this issue, it was probably maybe a year or two ago. But I just like saw some statistic online that like out of like all the physical waste or pollution in the world, like 50% of it was just, like from construction, like the was like end result of like any like buildings, because obviously no one in the past before like 1960 even thought about what happens to the building at the end of its life cycle. How is that planned for in the LCA, I guess?
Yeah. So we definitely include end of life in life cycle assessments. I mean, the issue is that people are interested a lot in waste, but the reality is, at least in the US, disposing of something doesn't have a high carbon footprint. And what I mean by that is, like, particularly if you look at construction and demolition debris, and it is true, we generate more construction and demolition debris in this country than municipal solid waste, mostly just because it's heavy, right? And so, but you can send that to a landfill and it just sits there. We're not really, in spite of what you might hear, we're not running out of landfill space. It's just that it may be that there are fewer people who want to have one in their backyard. So it could be we have to start trucking things further. And that obviously has an environmental impact associated with it as well. But still, in terms of the whole life cycle, usually the carbon footprint of throwing things away is very low. It just doesn't matter that much. What if we take that full life cycle perspective, though, there are some types of products where if we can make them from recycled content, that has a lower environmental impact than making it from virgin content. So in particular, metals, like the impact of making new aluminum, for example, is much, much higher than using recycled aluminum. So steel can easily be recycled, a lot of precious metals as well. So for me, the impact of throwing things away is not so much about the fact that it's sitting in a landfill. It's that then we have to generate sort of those new virgin materials, and the impact associated with that could be significant. So that's how I kind of think about end of life.
Yeah, that's really good to know. That's one of the biggest, like, honestly, just questions or like areas I was wondering about is just like the current state of like the end waste, like everywhere, because like I feel like no one really knows how like good or bad it is. And it really doesn't make sense that the building materials are honestly like some of the lesser of like what is going to be put out there in a landfill that will like cause damage to like an ecosystem. Let's say like a lump of concrete isn't going to hurt like nature as much as, like plastic.
Yeah. Well, even still with that, I mean, it really depends on what kind of landfill you're talking about. So, like, for example, in the US, we have a lot of regulations on how you create a landfill. And so what kind of lining goes in the bottom of it, right? And the reason that's because you don't want anything that's in there to then seep out into groundwater that's underneath and things like that. So now there are a lot of developing countries where they don't do a landfill, they just do a dump, right? They just start putting stuff, just piling it up in some place. And I spent several years studying waste in India and saw those. Now that can definitely be a local environmental hazard. So that's kind of what I want to differentiate, right? I'm not saying that, like, I'm saying it has minimal environmental impact if it's done correctly, right?
Yeah.
Or even in the Northeast here, we incinerate a lot of our waste too. And so, but that if you have proper incinerators that can capture the emissions, then that also doesn't have to be a significant local environmental hazard. So like I said, I try and avoid throwing things away, not because I'm worried about where it's going to go after that. Like, that's not going to have a big environmental impact. It just means that then the next time I use something else that could have used that material, that has to be new raw materials, right? So for me, that's kind of the life cycle reason.
Mhm. Yeah, that clarification means a lot too. And I never even thought about the fact that there's different like levels of like landfill or like dump. Like obviously from just like literally setting a space and throwing everything there to
Yeah.
actually having it like set up like with like the layering, I think
Yeah.
seep out and
Yeah.
leaching.
Yeah.
Um, yeah,
Or organic waste is like the exception to that. Anything that decomposes, um, in a landfill, if it's not exposed to air, it actually generates more methane. And methane is a much stronger greenhouse gas. It has like 25 times the potency of just carbon dioxide. So trying to avoid sending that to a landfill is more important, because that actually is going to decay, as opposed to plastic or metal or whatever. Like, that's just going to sit there. It's not really going to decompose much at all.
mhm. Yeah, that's good to know. So you kind of have gone over like the goals that you guys have at the Concrete Sustainability Hub. What are some of your guys' biggest like successes in research so far, and then I guess for the current things you guys are working on?
Yeah, I mean, I think the big thing that we have been able to demonstrate is the importance of taking that life cycle perspective when thinking about materials. Like, everyone, regardless of the product, everyone tries to say, oh, this is a sustainable product because it uses recycled materials, right? But that's only a small part of the overall life cycle impact. So, for example, when you take the whole life cycle perspective, like the example I gave with buildings, the vast majority of the environmental impact is going to come from what we call the use phase, or the energy associated with heating and cooling the building, right? So if you could, it could be that you need to use a non-green material, something that has, the material has a higher environmental impact, but if that then enables you to lower energy use throughout the building life cycle, that's almost certainly a trade-off that you're willing to make. And similarly with pavements, it turns out the way we design and maintain our pavements affects the fuel consumption of the vehicles that drive on them. So like a smoother road and a stiffer road leads to less fuel consumption of the vehicles that drive on them than the opposite, than a really rough road, or one that deflects a lot. So the kind of material choices that you make actually have a more significant impact throughout the life cycle. And so taking that more holistic perspective is, I think, a big thing that we focus on. And that's something that surprises a lot of people, because they assume we're just trying to develop more green concrete, when the reality is we're actually much more interested in trying to get people to take this life cycle perspective and consider things more holistically.
Yeah, to understand the whole system instead. Yeah, that's
Mm-hmm.
that's a really important side. Random side question. I remember like 5 years ago. I don't remember where I saw it. Um, if it was on like some like on the internet or what. But there was like a company that was like trying to make like a thing that would like essentially like lead to the replacement of like roads being concrete, and they'd be like paneled like solar panels that could
Mm-hmm.
like program it, and like so for like
Yep.
a parking lot you can change the line around, and then like they're more like resistant. You can just swap one out instead of like having to repave a whole road if like one is damaged, and obviously there's solar panels.
Yep.
I remember like thinking that was like really cool like years ago, and then I've definitely never heard of it since then. Is that like a thing at all?
It's really hard to do it. So it turns out like the whole way that we design pavements is based on the amount of truck traffic. So like cars aren't really heavy enough to impact much about like the deterioration of pavements. It's all about the amount of trucks just because they're a lot heavier. So designing a system like that to really handle truck traffic, I think, is what's challenging. And that's what you see. So even, I don't know if you've heard of pervious pavements, which is where basically water can flow through them. They're much more like a sieve. So in places where you're dealing a lot with water runoff issues, doing a pervious pavement is great, because then rather having the water run off the pavement to the side where it all collects, it just goes through the pavement to a drainage system. So that's great, like particularly in parking lots and stuff like that. But you can't really, at least right now, use it in mainline pavements just because it's not strong enough to be able to handle that. And so that's my skepticism with something like that, you know, like sort of these pavements of the future with solar panels. It's like there's a lot of durability issues, and particularly in areas where you have real winter. Actually, they can get really hot, really cold, you know, they go through a lot. And so I'm not saying you'd have to overcome before you could do that.
Yeah, that makes a lot of sense. Yeah, and I never. That's something I also never
Yeah.
understood is like whenever you see like the road signs where it says like 14-ton limit. I was like, I was always curious of like what that specified to it. It's literally just that for like the sake of like the concrete
Sure.
not breaking down.
Yeah. Yeah.
Uh, but yeah, if you want to continue about concrete sustainability, how about are there different things you're working on now?
Yep. I also spent a lot of time. I'm a faculty fellow in MIT's Office of Sustainability. So, like one of the big efforts I'm working on there is quantifying MIT's Scope 3 emissions. So, for companies and organizations, they will usually quantify what they call their Scope 1 and 2 emissions. So, Scope 1 is basically direct emissions from buildings and vehicles. So if you're like burning natural gas on site, then that's Scope 1 emissions, or if you have vehicles, then greenhouse gas emissions from that is Scope 1. Scope 2 are indirect emissions associated with purchasing electricity. So you're not generating electricity on site, but you're buying it from someone. So you can find a lot of entities that have been reporting Scope 1 and 2 emissions for a long time, you know, for 10, 15 years, something like that. Scope 3 emissions are everything else. They're emissions associated with everything that you buy. So we call that purchased goods and services. So like Apple doesn't, they like barely make anything themselves at all, right? So they have low Scope 1 and 2 emissions, but their Scope 3 emissions are large, right? So everything that they pay contract manufacturers to make is Scope 3 emissions. And then also they call them value chain emissions because it can be upstream from a company and downstream as well. So then when you deliver something and your products are used, those are Scope 3 emissions also. They quantify emissions associated with waste. And employee commuting, business travel, those are all Scope 3 emissions. So it's like it's a much more comprehensive perspective on what your real carbon footprint is, rather than just what's happening in your buildings. So that makes it much more interesting, but it also makes it more challenging because it's a big data challenge to be able to collect the amount of data to be able to quantify something across some large organizations. So that's a big effort for me in the Office of Sustainability. And then I also have a project looking at what we call hand printing. So we have an effort in our research group called SHINE, which is Sustainable and Health Initiative for Net Positive Enterprises. And you can look up more of it at shine.mit.edu. But it's basically, the idea behind it is that we can spend a lot of time quantifying our environmental footprints, but there's only so much we can do to lower our footprints. Meaning that, you know, we can you ultimately get to a point where basically there's only so much that you can do. Whereas hand printing is like, what are positive actions that we can take to basically lower the footprints of others? And so the idea is that if your handprint is larger than your footprint, then you're net positive. And so it's a newer idea, and one that we're trying to work on, in particular with companies who are like, we don't want to do greenwashing and just, say, hey, we eliminate all this footprint by taking one action. How do we be rigorous about quantifying these methods? And so, so that's another kind of interesting topic as well.
So is that kind of like the carbon offsetting industry? That's something I learned about recently too, where it's like, at least the examples given there a lot of times is where if a company either has reached the limit of what it can do for like the processes it has to handle, or if it doesn't want to make changes on its own process, it can like still give money to like, basically like you said, make a handprint, like offset carbon elsewhere, so they're net positive.
Sure. Yeah, I mean, it has some similarities. I'd say a little bit different is that with our hand printing effort, we're specifically trying to look at actions that would not have occurred without the entity really being involved. And so we're trying to have a tighter connection between an action someone could take and then an impact. Whereas offsets, as you said, if you're just kind of, exchanging dollars, then there also is questions about what is the real impact of the offset action. And so, there are some similarities, but we're trying to get a little bit tighter connection between the action that someone takes. So rather than like kind of going through a third-party vendor, what are ways that you can directly engage and then cause that impact to occur?
Gotcha.
Yeah.
I'm trying to wind down now. So what are
what maybe what I was just going to say, maybe tell me a little bit about what you said. You're graduating this term, is that right?
Yep.
So what's next for you?
So honestly, I studied economics here at IPY in Indiana University, Purdue University, Indiana. But I've always been much more passionate about entrepreneurship. Economics is always something that was interesting to me, and honestly, it was just get me out of here fastest because I wanted to focus on entrepreneurship. And I kind of like the switch you were saying you had when you switched from like engineering to wanting to be in this industry and had to relearn. I kind of found myself in that space a couple months ago because I realized I really just want to work in the sustainability space, make something of value there. But then there's this big kind of like gap you reach, or like just wall of knowledge that you hit. Like can't go further without like learning a lot about this to find where the gaps are, where the need is. So I figured I've done like random research about things before and like projects I wanted to do, where I ended up just like reaching out and having conversations like this with people that I trust on the information. And I figured with what I want to do now, I might as well like do it as a podcast, just because any other people in my position that want to dive into the sustainability field and become entrepreneurial or researchers or just understand it better, it might be useful to them. So honestly, just thought this was a good route for me to get that kind of just
That's
like
great.
crash course education on things.
Yeah. So you and sorry, you're finishing your undergrad, is that right? Or
yeah, I'm finishing my undergrad.
Okay.
Actually, so I'm about to finish my undergrad. I'm working like separately, like in real estate things right now, which is also interesting to me. But yeah, this is kind of like a side project that I'm starting just so I can basically for the next step forward so I can get there.
Yeah. Well, a couple of things that I would recommend. There is, like I said, for some of these areas, there is like a Center for Industrial Ecology or International Association. So go into their website. They have a bunch about sort of different topics that they're doing, and I mean, going to a conference or something, like conferences obviously aren't really happening much right now, but even online forums, looking, like I said, just starting to do a bit more research in this field of industrial ecology, because it's very multidisciplinary, and so there's definitely economists that are involved in that, and then I'm also involved in this in organizing this meeting called International Symposium on Sustainable Systems and Technology, which is kind of a mouthful, but ISSST. and so like just trying to find out what are some of the topics that people are doing, what are some of the methods that they're using. I talked about some of what I do, but that's not the only game in town, right? And so trying to find out a bit more about that, I think, could be helpful. And those are just a couple of organizations where you can sort of see like what's the type of research that's being published, and so that could be a good place to start as well.
Yeah, I always like appreciate hearing
Mm-hmm.
basically any just more for the things resources. I love that like MIT for one even just has like MIT Open Courseware, which is like really,
Yeah,
like basically taking classes.
exactly. So
Yeah,
like the industrial ecology course that one of my colleagues taught, that's on Open Courseware, for example, and so that's a good introduction to some of the methods and things like that.
mhm. But honestly, yeah, I guess to finish off, one actually the last question before we finish
Yeah,
off.
sure.
Are there any books that you would recommend or that mean a lot to you in anywhere in this space of either sustainability or thinking about these things analytically, um, engineering new systems like this, anything related?
Sure. Yeah. The cradle to cradle one that I mentioned is a kind of a good introduction to thinking about material systems. And then the other one that it shares quite a bit with economics is natural capitalism.
Mhm.
And so that's thinking about, not just economic capital, but also natural capital as well. And so those are some good introductions to sort of how do you have a different mindset for thinking about materials and environmental impact. So
Perfect. Well, yeah.
great.
Any last words that you want to say to, I guess any potential listeners that might want to get into the space or create things?
Um, Stick with it. It's worth what we need as many people as we can in this field. I think the biggest challenge that we run up against is just behavior change, like trying to get people to try something different. And so that's why it's great to have people who are willing to try something different or maybe not stuck in their ways jump into this field because that's really what it's going to take. If we keep doing the same things the same way we've always done them, then we're not going to have any change, right? And so there are different ways we can try and convince people to change, and some of it is with numbers, but some of it is even just like we need more social scientists in this space, right? Like how do you actually get people? You can convince them this is the more, this has lower environmental impact, but how do you actually get them to do it? And so it's a really multidisciplinary challenge. So
Definitely, I love it. Well, yeah.
great.
Thanks again.
All right,
For
you got it.
the time and the insight.
You're welcome. You're welcome. All right, take care. All right, bye-bye.